All right, this lesson is going to be 10-8. We're working on volume of prisms. Yesterday we learned about prisms, and if you go back in your notes, the front, you're going to see down at the bottom where it tells you that prisms have two parallel congruent bases. That means the top and the bottom are the same, and they have to be polygons, so they have to have the straight edges, and that everything in between are going to be rectangles. Remember when you do this that squares are also rectangles. So for volume, we are finding out how much it takes to fill a space. So when we started geometry, and we talked about a classroom, and this was the floor of the classroom, and we said we wanted to build walls. So we were going to go around. That was perimeter. The next thing we did, let me go ahead and write around. The next thing we did was we wanted to put carpet in. So that is going to be our area. That's all across the bottom. Today, we're going ahead and now we're using the three-dimensional shape, and we actually want to fill the entire shape, or not polygon, polyhedron, with material or water. Good way to think of this is like a fish tank. How much water do you need to fill the fish tank? So for volume, this is a cube, just a clear cube. Remember right here on the side where the faces connect is an edge. When they all come together in a point, that's our vertex. So then I'm going to take this cube and I'm going to fill it with rice. Well, if I was going to do a math problem to figure out how much rice is going to fit in this shape, that's when I am determining volume. How much is going to fit? So there is a specific formula for volume. It is capital V is equal to capital B times H. V stands for volume. Capital B is its base area. And then height is the H. What that means is when you go down, I have a problem worked out for you. Steps over here, you're going to find the area of the base. Be really careful. Sometimes the base is a rectangle, which means that your area is going to be length times width. Sometimes it's going to be a triangle. It can be other shapes, but that's all we're going to work with. And for triangle, the area is 1/2 little b times little h. Really important that you notice that today is a capital B. That is the base area, not just the base of the shape. It was looking a little blurry. Wanted to fix it. Okay, so right here we're going to start. Remember, we're looking for the volume. How much space is in the polyhedron? All right, so if we wanted to fill this, how much space do we need to fill? Well, first thing we're going to look at is the base, the rectangles. So this is going to be our bottom down here. And we're going to do area is equal to length times width, which we're going to do area is equal to 36 inches times 80 inches. When we multiply, we get 2,880 inches. I know that's hard to read. I had made a mistake, so I went back and fixed it. So now that we have found the area of that bottom, the base, we change our capital A into the capital B since we're working with volume. So we're going to now, for step 2, we're going to use the area of the base, which is what we just found, and multiply it with the height of the 3D object. How tall is it? So base times height, 2,880. Remember, we got this B, from right up here. and then times 20, which is the height. Multiply those together. We get 57,600 inches cubed. Volume, the answer for volume is always going to be units cubed. With me? So to review, find the area of the base. So you're going to do length times width. That becomes your base area. And then you go ahead and you multiply it times the height. I know a lot of you are thinking, well, why can't I just do length times width times height? You can on these because these are the easier volume. Later you won't be able to. So you need to be really careful, just like I've told you all year. Learn the correct formula so that when it gets harder, you already know how to do it. You would do the exact same thing if you were working with a triangular shape, except you would use this formula. So go ahead and grab your book. And open up to page 526. And we're going to look at number 1. I've already worked this one out for you, but I do want you to go ahead and go over it with me so you know how I got the answer. So first thing I did, and on all 3 of these, 1, 2, and 3, we're going to use the formula for the area of a rectangle. So we're going to do length times width. So length times width is 81. So that area now changes over to our base area. We're going to take that and move it here, multiply it by the height. We're going to get 162 centimeters cubed. No, I'll call back. Okay, on the next one for number 2, you're going to do length times width again. So here this is easy. This is a cube, so we're going to do 4 times 4 times 4. But again, we want to work it out, and we're going to do 4 times 4. So on your paper, 4 times 4. 4 times 4 is 16. Go back and check. We are working with inches. So our base area is 16 inches squared. We're going to take that and we're going to move it over to our base area for this capital B. It's going to be 16 inches squared times the height of our shape, which is 4. Put the 4. 16 times 4. 4 times 6 is 24. Put the 4. Carry the 2. 4 times 1 is 4. Plus 2 is 6. So the volume of that cube is 64 inches cubed. Correct. Okay, you're going to do number 3 on your own. We will grade it in class on Wednesday. But then let's go ahead and look at number 4. Number 4 is the same thing, except that now our base is a triangle. This is where it's going to get a little bit tricky. Up in the rectangles, it really does not matter what you choose as your length and your width or your height, because they all just get multiplied together. In a triangle, it does matter in that it will make a difference later as you get into harder math. So you want to find your triangle, which is right here. And for triangle, the formula for area is 1/2 base times height. And remember, the height of a triangle goes from the top straight down. So it goes from its vertex straight down. On right angles, that's super easy to find. It's going to be the straight line. They told us it's 6 meters and the base is 9 meters. So we're going to plug that in. And here, I think what I said a minute ago, I flipped these and I put 6 down as the base and then 9 down as the height. If you remember in our properties of multiplication, we can flip the order that we multiply and we're still going to get the same answer. So 6 times 9 or 9 times 6 is going to be 54. Half of that is 27 meters squared. Area is squared, volume is cubed. All right, so same as with the rectangles. Now we take our base area and we bump it over here into the spot for our capital B, our base area, and we have 27. Now we're looking for the height of the prism. And here, it's like you're standing it up on the triangle. So here's a polyhedron. It's not a right triangle, but we'll show you. This is the triangle. These are the rectangles. When we stand up the triangle, the triangular polyhedron, we're gonna stand it up using the triangle as its feet and as its head. So the height comes into play right here on the side with how tall is it from the feet up to the head. And in this case, it tells us it is 13 meters. So on your notes, you already have the 27 times 13. Over here, I did the math for you. This is multiply and this is add. And you're going to get 351 meters, again, cubed. And cubed is for what? Volume or area? Volume. Right, good. All right, go ahead and turn the page. Okay, when we look at number 5, this is what I was talking about on the previous problem. To get the height of a triangle, you go from the vertex straight down, and you need to make the right angle. So this purple actually matches this block that I have. So to find the height, we want to go from the tallest spot and then straight down. So we start with the vertex and straight down, and then that would give us a right angle. So here, for our base across the triangle is 8 feet. The height of the triangle is 4 feet. So 8 feet times 4 feet is 32 feet. 32 feet divided by 2 or times 1/2. Those of you who need it worked out, 32 divided by 2. 2 goes into 3 one time. 1 times 2 is 2. Subtract. Bring it down. 2 into 12 goes 6. So our base area is 16 feet squared. Go ahead and put that right over here. This was a capital B. This is going to be 16 feet squared times, again, the height of the entire polyhedron, which is 20 feet squared. Okay, multiply 16 times 20. Go ahead and put my 0. 2 times 6 is 12. 2 times 1 is 2, plus 1 is 3. My volume is 320 feet cubed. Okay, you're going to do number 6 on your own. We'll grade it in class. You're going to do number 7 on your own, and we will grade it in class. Number 7 is a story problem, but this is the formula that you're going to use. It has a really nice picture. Use the picture, read the problem. You're going to be able to understand. Realize that the question is not asking how much the area is, or how much the volume is, or what the perimeter is. It's saying, will the worker need more than 3 feet cubed of concrete? So when you figure out the volume of this ramp, if it is more than 3 feet, then yes, he will need more than 3 feet of concrete. If it is less than 3 feet, then no, he will not need more than 3 feet of concrete. Okay, moving on to the blue box. I wanted to go over GCD with you. One more time, remember GCD stands for our greatest common divisor. I know Mrs. Rachel used the ladder method for this, but I don't know it. So if you know the ladder method and you're confident, go ahead and use that. What I did was I went ahead and I did a factor tree for each of these numbers. So we are looking at 12, 18, and 24. On here, 12, you're going to keep breaking it down, breaking it down, breaking it down till everything is prime. So we're going to have 2 times 2 times 3. 18, break it down, 2 times 3 times 3. 24, break it down, break it down, break it down, break it down, 2 times 3 times 2 times 2. We couldn't stop at the 4. A lot of you want to stop at the 4 because it's a small number, but it's not prime. It is composite and can be split into 2 and 2. Now, what you do is you go through and you look for a prime number in all 3 of the numbers you're working with. So we have a 2, a 2, and a 2. So we're going to write down the 2. Then we have a 3, and a 3, and we're going to write down the 3. This 2 doesn't have a partner in here, so we do not use it. This 3 does not have a partner over here, so we do not use it. 2s have no more partners, so we don't use it. So, because there's a 2 and a 3 in each number, you multiply. 2 times 3 equals 6. Your greatest common divisor, or GCD, is 6. Turning it over, I went ahead and I worked out number 28 for you. Go ahead and study it. 29, I've worked it out. You have to figure this. And on number 30, you have to do the whole thing. Okay, if you have any questions, as always, email me, trierschneider@yahoo.com. If you have any other questions, write them down and I will help you with them once you get back to class.